2.31. So we're finishing up 2.31 today. Today is going to be the last day that we go over 2.31. We will be finishing it up. Now, we started doing these yesterday. We did this one here, y equals 1/8 times x minus 3 squared plus 2. Because on these here, we're trying to find the values of h, k, p, and a, so that we can find the vertex, focus, axis of symmetry, and directrix. So this here is the first one we're going to be looking at today. Now, since it tells us y equals negative 1/4 times x plus 2 squared plus 1, we need to compare this to the general form, which is our y equals a times x minus h squared plus k in this form here. Now, for this here, again, we still need to find the values of h, k, p, and a. Because once we find these values here, we can plug them into the general forms for vertex, focus, directrix, and axis of symmetry to get the information that we need. Now, just from the equation, we know that the value of k is 1. And it would be positive because it's plus 1 plus k, so it would be positive 1. H, for this one here, is inside the equation, so the number would be 2. But would it be positive or negative 2? Negative, because the only way we can go from x minus h to x plus 2 is if the value of h is negative. So we have negative 2. At this point here, we don't know what p is yet, but it does tell us what the value of a is. A is negative 1/4. Now we can use the value of a to find p, because p is equal to 1/4a. And since we do have the value of a, we can say 1/4 times negative 1/4 to find out what the value of p is. And at this point here, we can just take that expression and plug it into the calculator. Let it do it for us. We can say 1/4 parentheses negative 1/4 and see that the value is negative 1. Questions on how we found h, k, p, or a? Now the vertex in the general form is the point h, comma, k. Our value of h in this case is negative 2, and the value of k is 1. Our focus, again, we would look at the general form for focus for our y equals, which is h, comma, k plus p. We know what the value of h is. H is negative 2. Now we will need to calculate k plus p. Well, we know k is 1 and p is negative 1. So 1 plus negative 1 is 0. Bless you. So we plug it in for the y value of the focus. We have negative 2, comma, 0. Our directrix in the general form is y equals k minus p. So this time we're going to calculate k minus p, which would be 1 minus negative 1. Well, our negative and negative make a positive. So 1 plus 1 is 2. And lastly, axis of symmetry, x equals h. So for us here, it'd be x equals negative 2. So vertex, focus, directrix, and axis of symmetry. Yes. Yes. Questions on this here? Because the main goal of this here is to find the values of h, k, a, and p. We find a to find p, and once we get that, we plug the values into the general form for h, k, and p, and simplify where needed. We have to simplify our k plus p and k minus p. Questions on this problem? Are you ready for the next one? Now this one here is a little bit different because the general form is not y equals, but is x equals. So we match it up to the general form, it'd be x equals a times our y minus k squared plus h. That does not change what we have to find. We still have to find the value of h, k, p, and a. Now the equation told us what a is. A is what? 1/16. As the number that's taking the place of a is 1/16. What's our value of k? It would be 3. Now it would be positive because in the general form it's y minus k, and here we have y minus 3. So since the sign isn't changing from the general form to this form, it would have to be positive. Now if it had said y plus 3, then yes, it would indeed be negative 3, because we see a sign change from y minus k to y plus 3, and the only way that sign can change is if that value of k is negative. And what's our value of h? 1. Would it be positive or negative? Positive. It's outside that parentheses. Plus h plus 1, it's going to be positive. If it had been minus 1 outside that parenthesis, it would be negative 1. Last thing we need to find is the value of p. P is equal to 1 over 4. A. A is equal to 1 over 4p. P is equal to 1 over 4a. And the nice thing is that we can come in here and type in 1 over 4 times 1/16 and see that the value of a is, or value of p in this case is 4. So we found all this to be able to determine what the vertex, focus, directrix, and axis of symmetry is. Well, the vertex is going to be the what? Point, what? H comma k. So this would be 1 comma 3, because h is 1 and k is 3. Our focus is the point h plus p comma k. So k would be 3. Now we do need to calculate h plus p. In our case, h is 1 and p is 4. So we'd say 1 plus 4 is. So the focus is the point 5, 3. Directrix, x equals h minus p. So that'd be 1 minus 4, which is negative 3. And last but not least, the axis of symmetry y equals k. Well, the value of k is 3. That's it. The biggest thing to keep track of is making sure that we have the correct values of h and k, because with y equals, the value of h is inside the parentheses, k is outside. X equals, k is inside the parentheses, h is outside. But the easiest way to keep all this straight, in my opinion, especially with these equations here, is just to line them back up. What is going where? What is matching up with what? Because here we have y equals x plus 3 squared minus 5. And that's lining up with our y equals a times x minus h squared plus k. Yes. This one? Yes, that should have been it. Okay, thank you. There we go. That looks better. That way we know for sure which one it is, and if you go back to watch it, it's not going to be confusing. So if we look at this one here, let's start with k. What is k's value? -5. H is going to be -3. Now the question is, what's the value for A? 1. Since there's not a number written in front of it, it's understood to be 1. Now we can't say 0 because the parentheses are there. They do exist, because if it was 0, multiplication of 0 is 0. We wouldn't write it at all. Now the only thing that leaves us with is the value of P. P again is equal to 1 over 4A. We know what A is. A is 1, yes? So 1 over 4 times 1 is just going to be, well, 1 over 4, 1/4. So we have all the information we need to find the vertex, focus, directrix, and axis of symmetry. Now the vertex would be the point what? -3, -5. Focus is h comma k plus p. Well, we know what h is. It's -3. K plus p we need to find. Now k is -5. P is 1/4. So we're having to add -5 and 1/4 together. So -5 plus 1/4 is -19/4. The -19/4 is also -4.75. Or -4 3/4. Are all these the same number? Mm-hmm. You just need to pick which one you want to use. So we could say -4 and 3/4. As long as it is the same number, I will take any one of these three forms. The only time I will be more specific, especially on one of these here, is if instead it was, say, -4 and 2/3, where we get that 0.3 repeated, we have the repeated decimal. I prefer it in either fraction, improper, or as a mixed fraction, like this here. Either improper or mixed number repeated decimals, let's keep them as fractions and not as decimals, so we don't have to use our approximation, our rounding bar, our repeated bar. Now, for directrix, we have to do k minus p, so negative 5 minus 1/4. Let me say negative 5 minus negative 21 and 1/4. Negative 5 and 1/4. Negative 5.25. And normally for equations, we would try to avoid using negative 5 and 1/4. We would want to use a mixed number or an improper fraction or a decimal, but I will take, for these here, these mixed numbers. And the last one, the axis of symmetry, x equals h, so x equals negative 3. But again, the biggest thing with this, yes, we need to find the values of a, h, k, and p. Once we find those, we plug them into their corresponding spots and simplify where needed. Questions on any of this here? Do we feel comfortable with this here? Yes? Okay. I'm going to give you the last 20 minutes, or a little over 20 minutes, to work on the homework.